Hi and Assalamualaikum. Today we will present about simple GPA calculator. And this is our group members. First, project summary. This project aims to develop a simple GPA calculator that helps students calculate their grade point average accurately. The calculator allows users to input subjects, assign credit hours, and select grades for each subject. Based on this input, the system automatically calculates the GPA using a standard grading score. The purpose of this project is to make GPA calculation easier for students without needing manual calculations or spreadsheets. This tool provides a quick, user-friendly, and reliable way for students to monitor their academic performance. The system will have a simple interface so that all students, regardless of technical skills, can use it easily. The final output is a clear display of the calculated GPA, which students can use for self-assessment and academic planning. Second is objective of the project. The objective of this project is to design and build a simple GPA calculator that helps students calculate their grade point average quickly and accurately. The calculator will collect key details such as the number of subjects, subject names, credit hours, and grades received. It aims to make GPA calculation easier by handling the process automatically. The system will convert letter grades into grade points, multiply them by credit hours, and compute the GPA using a standard formula. The calculator will also provide feedback based on the result. For example, students with a GPA above 3.5 will see an excellent message, while others will receive encouragement or reminders to improve. Overall, this tool helps students save time, monitor their academic progress, and plan their studies more effectively.
So, I'm going to explain the concept of input, output, and process, which is known as IPO. This is a very important concept in programming and system design. So, let's get started. So, the first one is input. Input refers to the information that we provide to a program in order for it to perform a task. Think of input like ingredients in a recipe is what we give to the system. So, in a GPA calculator program, the input includes the number of the subject, the name of each subject, the credit hour for each subject, and the grade received for each subject. These values are all entered by the user through the keyboard. So the next one, we're going to move to the process. The process is what the program does with the input. It is the logic, calculation, and the decision made behind the scenes. For the GPA calculator, the process includes, so the first one, converting each letter grade into a numerical grade point. The second one, multiplying the grade point by the credit hour to get the total points for each subject. Next, adding up all the points and all the credit hours. And finally, dividing the total points by the total credits to get the GPA. And the last one, this program also checks if the grade is valid and give feedback or achievement based on the final GPA. So the lastly is the output. So finally, we have the output. Output is the result that the program shows after processing the input. It's like the final dish after all the ingredients are cooked. So, in this case, the output includes the first one, a list of all subjects with their grades and credit hours. The next one, the total number of credit hours. The next one, the calculated GPA. A feedback message like excellent or need improvement. And the last one, an achievement status such as dean list or warning letter. So, to conclude, Input is what goes into the program, process is what the program does with the input, and output is what comes out the result we see. So, by understanding this IPO, which is inputs, process, and output, help us plan, write, and explain our programs clearly and effectively. Thanks for watching. So today I'm going to present a pseudocode that calculates a student grade point average, which is GPA, based on their subject, credit hours, and grades. So let's begin an overview. This pseudocode is designed to accept input for multiple subjects, convert later grades to grade points, calculate the total credit hours and GPA, and finally display the GPA along with an academic evaluation. Firstly, we have a function called getGradePoint. This function takes a grade as input and returns the corresponding grade point based on the standard GPA scale. For example, A plus or A written as 4.0, B written as 3.0, and F written as 0.0. If an invalid grade is entered, the function returns negative 1.0 to indicate an error. So the next one, we're going to move into the main program. We start by initializing by two variables, which is total point to store the sum of all grade points multiplied by credit hours. The second one, total credits to keep track of the total number of credit hours. Then the user is asked to input the number of subjects that are taken. So now we use for a loop that repeats for each subject. Inside the loop, the user enters the subject name, credit hour, and the grade. The program then calls getGradePoint to convert the grade to a numeric value. If the grade is invalid, the program shows an error message and repeats the input for that subject by decreasing the index. Otherwise, the grade point is multiplied by the credit hour and added to total points. The credit hour is added to total credits. So after the loop ends, the GPA is calculated by dividing total points by total credits. Then the program displays the subject list, including names, credit hours, and grades, followed by the total credit hours and calculated GPA. So based on the GPA, the program gives performance feedback, such as the first one, 3.5 and above is considered excellent. Between 3.0 to 3.59 is a good job. Between 2.0 to 2.99 is need improvement. And the last one, below 2.0 means at risk or which is seek academic help. Finally, it checks for special academic achievement, which is a GPA of 3.8 or higher earns the Dean's List. A GPA between 3.5 to 3.79 gets a certificate of achievement. Below 2.0 will result in a warning letter. All others get no special achievement. In summary, this pseudocode is a complete GPA calculator that helps students understand their academic standing, receive appropriate feedback or recognition based on their performance.
Hi everyone, today I will present a flowchart that demonstrates how a GPA calculator program works. This program calculates a student GPA based on their grades and credit hour for each subject and then evaluate their academic performance. First, we will begin the flowchart with the start symbol. In the beginning, we will initialize three variables, which is total points equal to 0, total credit equals to 0, and I equal to 0. This variable will help us to calculate the total grade points, credit hour, and manage the loop for subject. Next, the user is prompted to enter the number of subjects they have taken. A loop is then initiated, checking whether I is less than num subject. If the condition is true, the program proceeds to ask for input like the subject name, the credit hour, and the grades. The program will convert the grade to a grade point using a function called getGradePoint grade I. If the grade is invalid, it returns -1 and the program display invalid grade. Then decrease I by 1 to repeat the current subject's input. For grade point calculation, if the grade is valid, the program will calculate the total grades point for the subject by multiplying the grade point with the credit hour. It then adds the credit hour to total credit and the increment I by 1 to move to the next subject. Once all subjects are processed, the GPA is calculated using formula GPA equals to total point over total credits. The program then displays the GPA, list of subjects, and total credit hour. Next, the program will evaluate the student academic performance based on their GPA. If GPA is 3.8 or above, the student is placed on the dean list. If GPA is 3.5 or above but less than 3.8, the program will display excellent and awards a certificate of achievement. But if GPA is 3.0, feedback is good job. If GPA is between 2.0, it should need improvement. And if GPA is below 2.0, it will show a warning letter and the message at risk, seek academic help will display. After the GPA and the appreciate academic evaluation or message, the program will reach the end, which is represented by the final oval in the flowchart. This marks the completion of the GPA calculation process. All the necessary output have been shown to the user, and the program will successfully finish its task. For summary, the flowchart offers a complete structure for a GPA calculator, starting from taking user input, validating them, calculating the GPA, and finally providing meaningful academic feedback. It ensures that students receive the appropriate support and motivation based on their performance.
Now, we will explain the source code of our GPA calculator step by step so you can see how our program works behind the scenes from input to output. First, we include 3 standard C++ libraries. IOStream lets our program perform input and output, like asking for user input and displaying the GPA. IOmanip is used to control the format. For example, we use set precision 2 so the GPA appears with 2 decimal places. Strings allows us to handle text input like subject names and grades. This is the function prototype. It tells our program that we will define a function later called getGradePoint, which takes a string like A or B plus and returns a float value representing the grade point. By writing the prototype early, the compiler knows that this function will exist and can be used later. Our program starts running from the main function. Inside this block, we write all the steps for the GPA calculation process, including user input, calculation, and the final output. Here, we declare all the variables and arrays we need. The num_subjects variable stores how many subjects the user wants to enter. Array like subject name, grade, and credit hours store information for each subject. We use grade point to store the point value for each grade entered. The variable total points and total credits are used to calculate the GPA later. We use a for loop so the program can repeat the input process for every subject. Inside the loop, we ask the user to enter the name of the subject, the credit hour, and the grade. This repetition makes the program flexible. Whether the user has 2 or 10 subjects, it will still work. After the user enters a grade, we call our getGradePoint function to convert it. For example, if the user types A, the function will return 4.0. This point value is stored in the grade point array. We use a function here to keep our code clean and reusable. Next, we calculate the total grade points. For each subject, we multiply the grade point by the credit hour. This gives us the weighted points. We then add all of those values together to get total points, and also add all credit hours to get total credits. At the end of the loop, we divide total points by total credits to get the final GPA. Once all the data is collected and the GPA is calculated, we use Cout to display everything. We print out a list of the subject, their credit hours, and the grades. After that, the final GPA is shown clearly to the user. We also added a feedback system using the if-else selection structure. If the GPA is 3.5 or higher, we display excellent. If it's lower, the feedback changes based on the range. This helps users understand their performance level. This section is for special messages based on the GPA. If someone gets a GPA of 3.8 or more, we show a message Dean's List. On the other hand, if the GPA is below 2.0, the program shows a warning encouraging the user to improve. At the bottom of our code, we define the getGradePoint function. This function checks the grade entered and matches it with a point value using a series of if-else statements. If the grade entered is not valid, like typing G, the function will return negative 1.0, and we can display an error message. At the end of our main function, we write return 0 to indicate that the program has ended successfully without any errors. So overall, our program combines arrays, functions, loops, and conditions to create a functional GPA calculator. It is user-friendly and can give feedback and achievement based on performance. We also included error handling to make it more reliable. This is how our source code runs behind the scenes to deliver the final result to the user. Now, we will show the sample outputs from our program. We have tested it with different sets of input to see how it handles both high and low grades, as well as invalid input. Let's go through each example one by one. For the first test case, we entered 3 subjects to simulate a strong academic performance. The first subject we added was math with 3 credit hours and the grade entered was A+. Next, we added chemistry, which has 2 credit hours and a grade of A. Lastly, we added physics, which is a 3 credit hour subject, and we also gave it a grade of A. Once all the inputs were completed, the program displayed a summary of the subject we entered, including the subject name, credit hour, and the corresponding grade. Then it calculated the total credit hours, which is 8, and displayed the calculated GPA, which is 4.00. Based on the GPA, the program displayed a feedback message, excellent, to indicate that the academic performance is outstanding. And under the achievement section, the program printed Dean's List since the GPA is 3.8 or above. This confirmed that the logic for GPA calculation, feedback, and achievement is working correctly when high grades are entered. For the second test case, we repeated the same process using the same subjects and credit hours, but this time we purposely entered lower grades to test how the program responds. We entered math with a grade of C, chemistry with a grade of D, and physics with a grade of D+. After entering the data, the program displayed the subject list again as usual. The total credit hour remains the same at 8, but the GPA calculated was 1.49, much lower than the previous one. Since this GPA is below the warning threshold, the program give the feedback at risk, seek academic help. In the achievement section, it printed warning letter which indicates that the students might need academic support or counseling. This shows that our program can handle different GPA range and give appropriate feedback and warnings to the user. In the third test case, we wanted to test the program input validation, especially for handling incorrect grades. So we started by entering math as the subject with 3 credit hours, but this time we entered the grade as G, which is not a valid grade in our program. The program detected this immediately and showed the error message, invalid grade entered, please try again. It then restarted the input for subject 1, asking us to enter the subject name again. This confirmed that the program includes input validation logic to prevent users from entering unknown or incorrect grades, which is important to maintain accuracy in GPA calculation. In our screen recording, you can see how the program runs for each of these 3 cases, from entering subject details to seeing the GPA, feedback, and achievement results. This practical demonstration proves that our program works well for both correct and incorrect input cases and produces reliable results based on the user's academic performance.
Lastly, conclusion. This simple GPA calculator is a reliable tool that helps students calculate their GPA accurately using their grades and credit hours. It uses basic programming to automate the process, making it faster and easier than doing it manually. The calculator works by multiplying each grade point by its credit hour, adding them together, and dividing by the total credit hours. This allows students to track their performance and plan their studies more effectively. In the future, it could be improved with features like grade prediction, saving past results, and a better design. Overall, it is a practical and useful project for students. That is all from us. Thank you.